Welcome in Kaidar. I'm going now to continue our parts for chapter 1. Let's start by types of mechanical waves. What are the types of mechanical waves? We have just only two types for the mechanical waves, which are transverse wave and longitudinal waves. And now we are going to make a very important comparison between these two types of waves, which are transverse wave, as I said before, and longitudinal wave. Let's start. As you see here in the transverse wave, the transverse wave consists of here crests and troughs, successive crests and troughs. Okay, these transverse waves are formed how? How they can be formed? The medium particles in the case of transverse wave vibrate perpendicular to the propagation direction. If my sound propagates in this direction, the sound of course makes compressions and reflections. These compressions and reflections represents by another type of wave, which is longitudinal wave. But if you throw a stone in water, this stone of water of course makes waves, and the medium particles, yes, vibrate perpendicular to the propagation direction. So this type, when the medium particles vibrate perpendicular to the propagation direction, this type of waves is called transverse wave. But when the medium particles vibrate along or parallel to the propagation direction, this type of waves is called longitudinal waves. So, as you see here for the transverse wave, and here for the longitudinal wave. Transverse wave, as I said before, they consist of, yes, crests and troughs. But for the longitudinal waves, they consist of, first of all, rarefaction, compression, and so on. Okay, please don't forget, the very important word in that definition of transverse wave is, yes, the medium particles vibrate perpendicular to the propagation direction. But the very important word for the definition of the longitudinal wave, yes, the medium particles vibrate along or parallel to the propagation direction. Here consists of crests and troughs, but here these type of waves, longitudinal waves, consist of compressions and rarefactions. What's about the definition of the wavelength? Wavelength, it is symbolized by lambda. Lambda, it is a symbol of wavelength. What's meant by wavelength? Wavelength in the case of transverse wave means the distance between two successive crests, or the distance between two successive troughs. If you have a trough, another trough here, so we have the distance between them is called wavelength. So wavelength of a transverse wave. Wavelength of a transverse wave means it is the distance between two successive crests or two successive troughs. That's for the wavelength of the transverse wave. What's about the wavelength of the longitudinal wave? Here we have rarefaction, compression, and as I told before, it is rarefaction, compression, and so on. So that's the distance between the centers of two successive rarefactions or the centers of two successive compressions. It is called the wavelength of a longitudinal wave. Also, we have a general definition for the wavelength. The wavelength, it is a distance between any two successive points having the same phase. It is a distance between any two successive points having the same phase. And as I told before, same phase means what? Means they have the same velocity, they have the same time, they have the same displacement, they have the same direction. They have the same velocity, they have the same time, they have the same displacement, they have the same direction. It means same phase, like this. Okay? That's for the types of mechanical waves. Also, we have very important questions for the give reasons for. The first question, which is, Electromagnetic waves don't need a medium to propagate. Why? Give reasons. Give reasons for electromagnetic waves don't need a medium to propagate, because electromagnetic waves, they are produced due to the vibration of two fields, electric field and magnetic field, and these two fields are perpendicular to each other. And these two fields are perpendicular to each other. So they don't need a medium to propagate. That's for the first question. About the second question, sound propagates. Sound propagates in gases as longitudinal waves only. Of course, in gases, what are the characteristics of gases? Gases, they are characterized by, yes, weak forces and large intermolecular spaces. So, if we have any gas, and this gas has a large intermolecular space, so it gives a chance for sound to propagate as a longitudinal wave due to the large intermolecular spaces and the weak forces. That's for gases. So, sound propagates in gases as a longitudinal waves only. But when I ask you, sound propagates in solids and liquids as transverse and longitudinal waves. In here, we can think about solids and liquids. Solids and liquids have, yes, stronger forces than gases. Also, solids and liquids have large or smaller intermolecular spaces, yes, smaller intermolecular forces, smaller intermolecular spaces than gases. So, this probability gives sound to transfer, to propagate as longitudinal and transverse waves. So, here, sound propagates in solids and liquids as longitudinal and transverse waves. Why? Due to the strong forces and small intermolecular spaces. And please don't forget, in longitudinal waves, the medium particles vibrate, yes, parallel to the propagation direction, along the propagation direction. But in the case of transverse wave, the medium particles vibrate perpendicular to the propagation direction. That's for these points. At the end, I hope to understood our parts for today, the types of mechanical waves, and understood it very well. Thank you, and follow us in the next part.